The title of our lab is Levitating Balloons Using a Tension Force to Find the Charge of Two Balloons. This is Group A, Section 2. Our goal in this lab was to find the charge of two balloons, Q1 and Q2. The balloons are charged with the same surface for the same amount of time so that they would both have the same charge. Based on the tension force of the balloons hanging from a string, the mass of the balloons, and the distance of how far the two balloons repelled each other, we were able to find the charge of the two balloons. For our hypothesis, the balloons will be of equal like charge and repel each other. This allowed us to find the charge of the two balloons, which turned out to be negative 4.09 times 10 to the negative 6th. For our experimental design, the two balloons were each tied to a string and hung from a surface. Both balloons were charged with the same fabric for the same amount of time. This allows us to assume the balloons have the same charge and the same magnitude of charge. As the balloons repelled each other, the distance was calculated for 3 different trials. This was plugged into an equation to give us the charge of the balloons. Limitations and sources of error include lack of method to ensure the balloons were charged to have this equal magnitude, and errors with measuring distance because the balloons were attracted to our hands when we brought the meter stick close.
In order to make our model as accurate as possible, we made sure to measure out equal amounts of string, blow up the balloons the same amount so that they would have about equal masses, and charge the balloons the same amount of time in an attempt to distribute the same amount of charge onto each balloon.
For this experiment, we chose to model it with the system schema and free body diagrams. The system schema includes the two balloons and the strings that they are both hanging from. There is an electric repulsive force between the balloons and a tension force between each balloon and the string it is hanging from. In the free body diagrams, we show that there is an electric force pointing in the opposite direction of the balloon it is repelling, a gravitational force that pulls downward on the balloons, and the tension force that acts on the balloons at an angle we found to be at a little over 80 degrees. The data we decided to collect for this experiment was the mass of the balloons, the length of the string used to hang each balloon, and the distance the balloons repelled from each other during each trial.
To determine the charge of the balloons, we had to use the concept of force in free body diagrams. The net force of the blue balloon is seen here and can be broken up into an x and y component. Since the balloon is not moving, the net force is 0, and the x and y force vectors should cancel out in their respective planes. Before determining the values of each vector, we had to figure out the angle made by the string when the balloons repelled each other. This was found using the law of cosines equation and plugging in the numbers to ultimately get an angle of 80.75 degrees. After that, we had to solve for the force of gravity, which came out to be negative 28.518. Consequently, the y component of tension becomes positive 28.518, since it is the only other force acting in the y direction, so it cancels out the force of gravity because the net force is 0. Then we solved for the x component of tension using Pythagorean theorem, and found that force to be negative 4.64. Although initially a positive value, we represent it as negative because of our reference frame. Now we know that the electric force is positive 4.64 since it is the only other force acting in the x direction, so it cancels out the x component of tension since the net force is 0. We can now use the electric force equation shown here to plug in the numbers and solve for Q, which is the charge. We found this charge to be negative 4.09 times 10 to the negative 6th. And since the balloons were nearly identical, we can assume that this was the charge found on the orange balloon as well. Since the balloon was electrically neutral before becoming charged, we found the electrons transferred to the balloon by taking the charge of the balloon and converting that charge into number of electrons. This gave us an answer of 2.55 times 10 to the 13th.